solving equations. An equation is similar to a balanced weigh scale. So a scale is a device used to test if two quantities are equal. You may have seen one of these scales in a science class. If the quantities on either side of the scale are equal, then the scale is balanced. And an equation is a statement that two expressions are equal. So for example, x plus 3 equals 5. And to solve an equation means to determine the values that can be substituted in place of the variable to make the statement true. Some equations can be solved by inspection, so just by looking at it. However, in many cases, the value of the variable cannot be determined just by looking at the equation. It must be determined algebraically. To solve an equation algebraically, the goal is to isolate the variable on one side of the equation by performing the same operation to both sides of the equation in order to maintain the balance. To eliminate a value from one side of the equation, you perform the inverse or the opposite operation. So we're going to start with some simple one-step equations. And again, you may be able to quickly look at these and determine what the value of the letter or the variable will be. However, some of them you won't be able to. And I want you to start by practicing really how to balance the equation using those inverse operations so that you can master it on these simple one-step equations so that as we progress throughout the unit and the equations get harder and harder, you understand what you're doing for each step. So we're going to solve lots of examples together, so you have lots of examples to refer to as you're doing questions on your own, but please reach out if you have any questions. Post your questions on the discussion forum within the virtual learning environment or send me an email and let me know if you are struggling or if you need some clarification. I know these are strange times, but it's really important as we get into some of these more complex questions and more complex skills that you truly understand what you're doing. So example A, we have z plus 3 is equal to negative 4. So I want to isolate z. So I want to get this letter z all by itself on one side of the equation. And your goal is to get a positive value for your variable. So we don't want to have a negative z, for example. We want a positive z, so a plus z. So it's already positive on the left side of this equation, so we're going to keep it here on the left-hand side of the equation. Well, that means we have to eliminate this plus 3 on the same side of the z, so on the left side of the equation. And we do that by doing inverse operations. So the opposite of adding something is subtracting something. And the opposite of multiplying something is dividing something. And the opposite of squaring a number is square rooting a number. And we looked at squaring versus square rooting when we looked at Pythagorean theorem. And we also looked at a little bit of this solving equations when we looked at Pythagorean theorem as well. So you may see some of those skills overlap. So knowing that those are the basic opposite operations to look at, so the opposite of adding 3 would be subtracting 3. So what I'm going to do is I'm going to subtract 3 from both sides of my equation. And I'm going to show this step here. So I've shown that from my z plus 3, I'm subtracting 3, and from my negative 4, I'm subtracting 3. So the great thing about that is that it eliminates from this left-hand side. So plus 3 subtract 3 is 0, so those two cancel each other out. So they're gone. And when we looked at algebra tiles, the same sort of thing happened. So when we had a positive algebra tile and a negative algebra tile, they canceled each other out. So that same sort of strategy works here when we're looking at solving equations. So I'm left with just z on the left-hand side, and negative 4 subtract 3 is negative 7 on the right-hand side. So now I have a value for z And if I wanted to, I could do that left side, right side check. So I'm using the original equation, so the left side, and sometimes we can do that by just showing this t-chart here. The left side of my equation is z plus 3, and the right side of my equation is negative 4. I'm going to substitute in negative 7 for my z, so negative 7 plus 3. And negative 7 plus 3 is negative 4. So the left side equals the right side. So I can say for certain that z is equal to negative 7. So I know that doing this left side, right side check, my answer here is correct. We're not going to do the left side, right side check for each of these examples that we're going to work through today, but this left side, right side check is a great strategy for you to use at home when you are practicing your questions to make sure you have the answer correct. And if your left side isn't equaling your right side and you can't figure out where you went wrong in that question above, then like I said before, please post your questions in the discussion forum or send me an email. So example B, we are keeping x by itself. So we have to eliminate negative or subtracting 8.3 from that same side. So the opposite operation or the inverse operation to subtraction is addition. So we're going to add 8.3 to both sides of my equation. So I have x minus 8.3 plus 8.3 is equal to negative 17.9 plus 8.3. So my 8.3's cancel each other out on the left-hand side, so we're just left with x. And then I can use my calculator to solve for the right-hand side. So I have negative 17.9, and I'm adding 8.3 to give me a value of negative 9.6. Now let's take a look at example C and D. So instead of adding or subtracting values to your variable, now we are multiplying. So the 4 times n means multiplication. So if it's helpful for you to write this down so you remember that. We've done a lot of this earlier, but that's really important. So 4n means multiplication, and the opposite operation for multiplication is division. So we are going to divide both sides by 4. So I'm going to have 4n divided by 4 is equal to 24 divided by 4. And remember that this fraction means division. So you can write it as a fraction, as I've done here, or you can write it out as 24 divided by 4. Either of those works. So 4 divided by 4 is 1, so these ones cancel each other out, so we're left with just an n. And 24 divided by 4 is 6. And again, you could do that left side, right side check to check your answer to make sure it's correct. So let's take a look at example D. So example D, we have a negative coefficient in front of our variable, but we're going to apply the same strategy. So instead of multiplying by negative 5, which is what's happening already, we're going to do the opposite of that. So we're going to divide by negative 5. So you're going to divide by whatever number with the sign in front of that variable. And that way our variable will stay a positive letter. So my next step in my equation will be negative 5w divided by negative 5 is equal to 42 divided by negative 5. So negative 5 divided by negative 5 is 1, so these guys cancel each other out. So we're left with w, and again I can use my calculator because this isn't going to work out to a nice whole number. So 42 divided by negative 5 is equal to negative 8.4. So it's okay to have decimal numbers. your questions aren't always going to work out with nice whole numbers as even though we might want them to. Okay, let's go through a couple of more examples. So as we said before, when we have a fraction, this means division. So we have to do the opposite operation, and the opposite of dividing is multiplying. So we're going to multiply both sides of my equation by the denominator. So I'm going to have 4 times a plus over 4 is equal to 4 times 8. And you'll notice I put these in brackets, and remember the brackets mean multiplication as well. So I have a 4 on the top and a 4 on the bottom. These guys cancel each other out, so we're just left with a. And 4 times 8 is 32. Our next example, so example F, again we have this negative value here. So we're dividing k by negative 3.4. So the inverse operation, or the opposite operation, is being multiplying by negative 3.4. And in order to keep that equation balanced, we have to do both sides. So I'm going to have negative 3.4 times k over negative 3.4 is equal to negative 3.4 times 6.5. So the beauty about when we multiply or divide by the same number, it gives us 1, so we're just left with k. And then again, because this isn't a nice whole number, we can use our calculator. So negative 3.4 times 6.5 is equal to negative 22.1. And again, you could do that left side, right side check to make sure you've done your question correctly. But as I said before, we're not going to do it for every question in these examples. So let's go through 2 more examples, and then you could use this lesson as a resource as you practice some questions on your own. So I have 3.6y equals 15.552. So right now I need to think about what is the operation that's happening between my number and my variable, and that's multiplication. The opposite of multiplication is division, so I have to divide both sides of my equation by 3.6. So 3.6y divided by 3.6 is equal to 15.552 divided by 3.6. So 3.6 divided by 3.6 is 1, so we're just left with y. And 15.552 divided by 3.6 is equal to 4.32. So unless it tells you otherwise, keep the decimal places if they're not too long. This is fine. So 4.32, it would be fine. If you really wanted it to round it to 1 decimal place, you could. So you could write 4.3, but 4.32 is just fine. So the last example we're going to do is H. So right now we are subtracting 12.545 from B. So the opposite of subtracting is addition. So we're going to add 12.45 to both sides of my equation. So I have B minus 12.45 plus 12.45 is equal to negative 3.75 plus 12.45. So the negative 12.45 plus 12.45 cancel each other out on the left-hand side, so we're just left with B. And then we can use our calculator to work this out. So negative 3.75 plus 12.45 is equal to 8.7. Now let's do a final left side, right side check just to keep that those skills front and center. So I'm going to have create my t-chart. So left side, right side. The right side of, or left side of my equation, sorry, is B minus 12.45. The right side is negative 3.75. I'm going to substitute the value that I found for b into my equation on the left-hand side. So I have 8.7 take away 12.45. And I'm going to use my calculator to calculate that. So 8.7 take away 12.45 is equal to negative 3.75. The left side equals the right side, which is what I want. So therefore, I can say with certain that b is equal to 8.7. So we've looked at solving simple one-step equations using inverse operations or opposite operations, and we can verify our answer by using the left side, right side checks, which we learned in our previous lesson.